Hello friends. So today we talk about the basic concept of hypothesis testing. So let's get started. The R&D have many questions they want to answer about their power solvent. So how does power solvent compare with products currently in the market? Does power solvent improve engine performance? How can they use statistics to answer their questions? To investigate any one of these questions, the R&D team can conduct a hypothesis test. To begin, the team needs to determine which questions they want to focus on and then determine their hypothesis. For now, they decide to focus on the first question: does the power lower fuel consumption effectively improve engine performance? They will compare their results with the industry standard of 3.10. Next, we need to define the hypothesis. A statistical hypothesis is a claim about a population parameter and determines what we actually test. The hypothesis should be based on our knowledge of the process, such as how a process has performed in the past or customers' expectations. For example, we may know that customers expect a certain result when using our products. In inferential statistics, we have two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis is a hypothesis that usually states that a population parameter, such as the population mean, equals a specified value or a parameter from another population. The alternative hypothesis is the opposite of the null hypothesis, so it usually states that the population parameter does not equal a specified value or another parameter. In statistics, the null hypothesis is represented by the symbol HO. The alternative hypothesis is represented by H1. The null hypothesis is also referred to as H0, and the alternative also may also be called H8. The R&D team wants to evaluate the effectiveness of their product by comparing it against the industry standard fuel consumption of 3.10. The null hypothesis is that the mean fuel consumption of a car after using their product is equal to 3.10. The alternative hypothesis is the opposite of the null hypothesis, that the mean fuel consumption of car is not equal to 3.10. Sometimes the alternative hypothesis is directional or one-sided. That is, we suspect the population parameter is greater than or less than some value. Suppose the R&D team wants to test whether their product is better than the industry standard. In this case, the alternative hypothesis is V less than 3.10. Suppose an automotive assembly plant has just received a shipment of 6,000 timing belts. Before sending these belts into production, a quality technician wants to examine them to decide whether they meet the required specification. In particular, the technician wants to know whether the width of the belt meets the specification of 1 inch. What are the null and alternative hypotheses? The null hypothesis is that the width of timing belt equals 1 inch. The alternative hypothesis is that the width doesn't equal 1 inch, the opposite of the null hypothesis. We can make two possible conclusions after analyzing our data. We can reject the null hypothesis and claim statistical significance, or we can fail to reject the null hypothesis. A common mistake is to say accept the null hypothesis instead of fail to reject the null hypothesis. Remember that we are making our decisions using sample data than the entire population. Therefore, the information we have is incomplete. We can never accept the null hypothesis because we can never be absolutely certain whether it is true. Let's review. We use hypothesis tests to find statistical answers to questions about our processes and products. The null hypothesis usually states that a population parameter is equal to a specified value or a parameter from another population. The alternative hypothesis is usually states that a population parameter is not equal to a specified value or a parameter from another population. Thank you for listening. In the next lesson, we'll use hypothesis tests to make decisions.